Hey there, my name is Alessio and I'm part of the developer experience team here at Spectacles. Today we're going to talk about connected lenses. If you're new to connected lenses, you can find this topic in many places in our ecosystem. The first place you can look for is in the homepage of Lens Studio. If you click on the Spectacles section, you can find all of the samples that we offer, including connected lenses, like air hockey, or laser pointer, or tic-tac-toe, or sync controls, and so on and so on. If you feel like building your project from scratch, you can also go on the asset library in the Spectacles section and look up the Spectacles Sync Kit package. This is the underlying technology of connected lenses, and when you import it in your project, you can start building things on top of it. If you like start from a GitHub repository, you can also go on github.com snapshot spectacles sample and clone this repository that includes all of our samples, including all of the connected lenses example that we provide. These are the same project that you find on the homepage of Lens Studio. So what is this project about? Think Out Loud is a connected lens that allows you really to quickly type what you're thinking and just display it on a bubble that is hovering on top of your head. And this bubble is visible to everyone that is part of this connected lens. And everyone can also quickly ping you with a pinch from the right hand. And that ping will send you a notification. You will be able to accept or reject that request that arrived through the ping of the other persons. Through this experience, you will be able basically to stream some information. You will be able to visualize some information from other users, and you will be able to interact with other users in a very interesting way, which is kind of this ping concept that we just prototyped in this example. Today, we're going to start with project architecture. Then the next session will focus on session management and user synchronization. Then we will go through custom sync entities for multiplayer features. In the following section, we will go through storage properties for persistent data. Next, we will go through network events for real-time messaging. We will understand how to test our project in the editor. And finally, we will wrap up with some quick references. So if you want to develop connected lenses, you must know about the Sync Kit. The Sync Kit is a developer toolkit that allows you to build connected lenses. These lenses are co-located, but you're actually not connecting or sharing. You're actually syncing values from one device to another, and these values, of course, are shared across the cloud. So there is the infrastructure. You go from Spectacles number 1 to the cloud, and then Spectacle number 2 to retrieve those sort of information. There are major features you must know when you get into this topic, and I think the key features are perfectly summarized in this part of our documentation. When you go on getting started, we have session controller, we have sync entity, we have storage properties, we have network events, we have the instantiator, and then we have some deep dive on the life cycle. To make it very short for you and clear and not overwhelming you with a lot of different concepts, session controller is the mastermind that controls everything. So it's really aware, it's sort of a centralized controller that knows about everything. The sync entity instead is like a general concept that also gets subdivided in sync transforms, sync materials, and other properties. Is really like the piece of code that synchronizes that specific type of information. Then we have storage properties. Let's say that you want to create a game where everyone is like achieving certain score and sharing these scores on a leaderboard. You will need to store those properties on the cloud and retrieve them or make them persist across sessions. Then you have network events, which is basically one-time messages that can just go across the network, can be broadcasted to everyone, or can just be broadcasted to a specific user. Network events are a really easy way to just subscribe to an event or receive an event, and it's just basically based on one single use of one-time message across the network. Then we have the instantiator, which you can also see more in detail here, is a manager that allows you to track all of the object that is being instantiated across the network. But without further ado, now let's get into the details of this project so you will have not an abstract understanding of this concept, but a very pragmatic understanding of how everything works together. So we just opened Lens Studio for our Think Out Loud Connected Lenses project, and the first thing we probably notice is the double preview here on the right. So you see here that you have two previews. And this is really for testing connected lenses, meaning that we can eventually enter as a multiplayer mode and we can test our lenses in the editor. What I want to focus now on is really how this project is being built and why the hierarchy looks like the way it does. You will see that there is a script folder that has a lot of subfolders. We try to keep very much things isolated and modular for you to understand what is going on and also to allow you to extend all of these utilities. We have audio, we have hand menu, we have hands, and then we have head label, ping menu, player, sync controls, and utilities. You might notice already something in this project. You notice that we have 3 managers, and then we have a line, and then we have other 2 managers. The pattern of all of these systems is having a manager in the scene that handles a controller, which is on the object that you've been instantiating. So let's go step by step through all of those objects and understand what these objects do. So the Spectacle Sync Kit is a prefab that you will import from the Spectacle Sync Kit package. So this is nothing I created. This was already available here for me to start my project with. You can find this package on the Spectacle section here, and then you can download it from the asset library. You will see Spectacle Sync Kit. When you drag and drop this prefab in the hierarchy, this prefab will have a certain setup. Especially, you will see that we have hidden from scene view, and then we have something called enable on awake. Then we also have something called collocated world with a lot of examples. And then we have all of these examples which we are not making use, but if you're curious and want to understand how they work, they're here available for you. Let's focus not really on what's already available on the asset library, but let's focus on how we set up our own lens based on those information. You will notice we have an instantiator script. This instantiator script is very, very helpful. Besides working as a fundamental piece of all of our network project, also help us to track all of the objects that will be instantiated in our scene. For example, you notice that we have a player object, a left hand and a right hand object, and then we have also something called head label. So just to translate what this is basically the head pose of all of the players. This is the left hand position, this is the right hand position, and this is a label which is hovering on top of the head. So this is kind of a very similar one, but this one just has a lot more feature that we will showcase later. But you know that for each player, basically, we will be able to synchronize, because these objects are instantiated through the instantiator, we will be able to synchronize 3 main positions, which is the hands of the player and the head pose of the player. With those positions, you can do quite a lot, and I will show you through this project. So for each of those, we actually have a manager. So you will notice that I had player object manager, which handle the player object prefab, the hand object manager, which handles the left and right object prefab, and then we have the head label object manager, which reference and organize the head label prefab. I say this because I want to show you how repetitive is this pattern and how you can easily pick it up. So there is a manager and then there is a controller. The manager handles the prefab that the instantiator instantiate initially. So the instantiator track all of those objects, then the manager handles all of those objects, and the controller is on top of those objects that are instantiated to reference the manager and kind of transmit what are the updates between the players that are in the network connected lens. Now we have also this additional section, and we have a hand menu, because I prepared a quick hand menu to have in this lens for you. And then we will have a ping menu manager that will allow us to choose between accept ping and reject ping. Okay, let's talk about session management and user synchronization. The flow that happens in this connected lens goes as the following. The user joins the session, then there is a session controller which enable notify on ready, and then we instantiate sync entities. These sync entities are the player object, the head label, and the hand objects. And then, in the second part of this application, based on the action that are handled by those controllers that are part also of the sync entities, we are going to subscribe events and retrieve informations. So starting from the Lens Studio side of things, you can see the player object manager, which is here, has a player object prefab, which we can right click and select on top of it. Then if we can double click on the player object, we will see that the player object has player object controller, and then we have a sync transform. So sync transform, as mentioned before, is a subset of sync entities. And in this case, what we're syncing, guess what it is the transform, which is this component that allows me to retrieve position, rotation, and scale of that specific scene object that in this case represent the head pose of the user. So you will also see that the player object controller reference directly the player object manager, so there is pretty much a tight relationship between controller and manager always, and this is true for all of the other prefabs. And then also holds an array of material which are assigned to distinguish between your hands on your head pose color and other players. In this case, because we have also a head label, which kind of will be a repetition of this player object process, I toggled off the object that represent the head pose of the user, which in this case is just a box with a flat color. So let's take a look in the scripts how actually this relationship look like, because we saw that in Lens Studio is pretty straightforward. Basically, a manager is in the scene, and then this manager holds a prefab, and this prefab has attached a controller and a sync transform. But via script, you can see exactly what's going on. You can see that the manager on start look at for notify on ready, which is already part of the framework of the instantiator. And then what does it do? It's instantiate a player object. So instantiate that player object, and then it's subscribed to the player object controller. So the player object controller, which is referenced here, by the way, so we know what the player object controller is going to create an event, and this event is going to be an update event that binds this on update, which is this function, and this function calls this my player object on update. Let's take a look what's going on in on update in the player object. We can just enter this function and see that here what we are doing is just tethering the object to the head pose of the player. And you will see, for example, here we get the camera position. This is a private transform. We get it here, and then we just create a little bit of an offset. In this case, it's just 50 centimeters ahead of us. And then that will be the position that we will try to maintain across the session. This is the way we subscribed on Notify on Ready. We also assign the color here. So we have an additional utility that assigns the color. If we have children, we also apply recursively the material. You notice also that on the controller, we do this on start. Basically, we get the sync entity, which is part of the same object that has the controller attached. So if we go back in Lens Studio and we go in the player object, this player object has a controller that we're going through and has a sync transform. So we get that sync entity, and then on Notify on Ready event, we assign the player color. And then we know that we have a distinction of local player and remote player. This part is very important to understand the ownership concept. Basically, if this sync entity is being locally created, we just update it because it's our. Otherwise, we just reference that scene object name with remote player. So we understand what's local and we understand what's remote. If we do this with every player will care about updating their own sync entity, and that sync entity will be synced across the network, and I will be able to see those objects in space, in this co-located space, which is part of this object here, this co-located world. Actually, something you could try sometimes, if you want to debug properly, is to use this button, and let's do it quickly. Now that we are entered in our session, if you click on this button, you will see everything that is happening on update. This button is called Inspect Preview. And if you go on Collocated World and you see all the children that are enabled on Ready, you will actually see all of these components that are part of our connected lens. So everything that is in our space, which is shared across the network. So you notice that this blue is something that is being instantiated. We say right, left hand, we set head label, and we say player object, and so on and so on and so on. So let's get into part 3. In this part, we'll understand how to go beyond this very basic setup that shows hands and show head pose of the users. The same way that we use the head pose between user A and user B, we can also use the same exact system also to showcase your hands, so left and right. Now, if we want to go beyond that and we want to start to create something a little more customized and like really going through all of the system that we talked about, we will need to do something quite different. Still keeping the same structure, but we are no longer syncing transform, we're actually syncing data. So let's see what is happening here. What is happening here is there are 3 main actors. That is the sender, the network, and the receiver. The sender ping requests, so it sends a request. Then the network passes it to the receiver. The receiver sees a notification with that request, and then there is a response. So request from the sender and response from the receiver. Then the receiver is going to just click yes or no, basically. Do I want to talk to you or don't I want to talk to you? And then we have a ping connection update, which is broadcasted to everyone based on that request and response. In this case, it's very easy and simple because my ping request is basically say, hey, do you want to chat? And the response is yes or no. And if it's yes, the color of my head label will change. And if I say no, the color will just stay as default color, so it won't change. So how to build a system like this that really will allow us to come up with the final part that we need to create this think out loud lens, which allows everyone to think out loud through their head label. So here we have two more managers. There is the hand menu manager and there is the ping menu manager. We won't be able to see the menus of other players, and players won't be able to see our menus. At the same time, we need a way to instantiate those menus and let the player decides for their actions or perform this action that we talked about. Also, another thing that I want to mention here, which I hope that will make more clarity, notice that the instantiator does not have any menu component, menu prefab, because actually those prefabs are not shared across the network. So we don't need to do that. Those menus are just for us to click on buttons, and those buttons will send events across the network. Those network events that we talked about. So here we have a hand menu manager and ping menu manager. The hand menu manager instantiates the hand menu prefab. There is a nice timer that is gonna just showcase the menu. And then we have a head label updater that will allow us to instantiate a menu really and just decide our sub status, and those two pieces of information will be synced on our head label. When it's synced on our head label, that information will be available for everyone to see. So see how asynchronous is the process. Before I update my information, then when I update those information, the information are available for everyone to see. And similarly to the head menu, the ping menu has a very similar structure. It gets the ping menu prefab and then has a nice notification if it turns on and instantiate the menu. And when you get that notification and the menu shows up, you will be able to basically choose accept or not now or reject this request. Let's take a look at the prefabs, how they are composed. Let's go on the hand menu first. The hand menu prefab is composed in this way as hand menu references, which is basically just a holder of all of the parts of this menu. In this case, we have a lot of buttons, which are the buttons that we will subscribe to trigger certain kind of events. And then we have the switch toggle group, which is also part of the sub state that we want to update on our head label. And then we will have a head label updater, which is the part that will update and will reference the head label object manager. We have, again, the controller here. The controller is what actually connect this information, which are just part of our local interface, to the network. So we start really to get all of these things and just put it on a network depending on what we want to trigger with those buttons, right? And then we have a frame component, which is really just the backplate that is holding our menu. So there's nothing relevant regarding the network system that we are creating. Here, an interesting part that we might take a look at this point is the hand menu controller. So let's check out the hand menu controller. So what I want to focus here is on this method that is the one that we will press for updating the status of our head label. So let's say that I write on with the keyboard, I feel great today, and I put as a substatus, let's chat or coffee. And I want to send that update and just showcase it on my head label. This is really what's going on behind the hood when I press update. On update status button pressed, we print some statement, and then we get basically the head label updater, which is the script that we referenced before that updates things. And then we just call something called update my head label status. And we pass our current status and current sub status. So once again, let's enter in this one and see what's actually happening. This is the head label updater. And the head label updater calls the head label object manager where we update the status. And once again, those strings are passed here. Let's get into the update my status. We're gonna get to the point of all of this, meaning that my head label will update the status. And this is really what's happening behind the scene for networked events. Here we are having this status text propped, and then we are set this value as string. And then we are also saving to the cloud, save persistent data, the status text and substatus text. If you're wondering where is that property actually being stored, where is it coming from, just to go to the end of all of the subsequent steps that we took, you will see here that that substatus and status are storage property, manual string, and this is just a placeholder for persistent data across session. You can also get the user info. There is a whole section in our documentation actually on how to retrieve user info. So getting into part 4, that is really connected to what we just said, if you're interested in understanding, well, okay, we set some properties, but where these properties come from, you can just go in this file, which is called head label object controller, and just check out all of these storage properties. And these are storage properties that are part of the connected lenses sync kit. And in this case, these are all manual strings. So we're just gonna save this as a placeholder. We're just gonna set them up as a placeholder, and then we're gonna update them across the session. If you go on our documentation, you can take a look at the storage properties page, where we have very simplified example to just get straight to the point to what's happening here. You will notice that we add storage properties to sync entities. So we already have sync entities. The sync entities are the ones that are attached to our prefab. And then we set those storage properties. We storage property for position, so we get transform. We storage property manual string, so for my string probably is one of the most used. There is also a distinction between manual storage properties, which are pretty much regular storage properties, like very common use like integer, strings, and vectors, local scale, transform, and so on and so on. You know, something that you want to sync. But eventually, if you go more deep into storage properties, you will also see that you can store properties that are custom. So in this case, you notice that this is being created another storage property called matrix, and we're storing a matrix, which is our custom type. So we just like create it here and we just reference it. We just give it like nominative to reference the properties, and we're good to go with our custom property here. You also notice here that what we did before, set pending value, meaning that we are setting this value of the store properties. You can update these properties in two ways. You can update immediately if you want, or you can more safely set pending value, which will update the next loop. You can do this by set pending value or set pending value immediately. So like this. Now we're going to talk about network events. If you wonder, well, I already know how to store data, read data, and set data. So why should I be worried about network events? Well, network events are really the perfect use for cases where you don't need persistence and you just basically just need to fire and forget. It's just something that doesn't need to be stored, it just needs to happen and not being recorded in your networking system. So we have a perfect example in our lens about this topic, which is setting the ping events. Because when I ping you, which means I just hover on top of your head, I target the bubble that you have hovering on top of your head and I pinch with my right hand. This is going to get pinged and will set a ping event. That ping event will be a custom event basically that I have here and will send a message, and that message will be handled. So this is going to handle ping request, this is going to handle ping response, and this is going to handle the ping connection update. So whatever happens after the response. This is really all you need to know about how to set up these events. But let's get into the handler so we actually can see what's going on in the handler. Now we are handling the ping request. So this is a very custom request that we're making, and we actually build it for this specific purpose. Let's read through this code and understand what's going on. First of all, I'm trying to get my local user info because I want to display to the other player that I pinged them. So you will get a notification that will say, hey, Alessio just pinged you. So I want to show that my user info are going into the request. So after we define who's the user ID or connection ID is, we are going to set a message info that has this sort of data. So request data are message info, so send the user ID to who, and then that will show the ping menu to the other person because this is the request. So let's go and check out what does it mean showing the ping menu, meaning that whoever is the receiver will get a notification and the ping menu that they have in their own local space will be finally triggered. Now we allow just to have one ping menu active at the time, otherwise we destroy it. And then we instantiate if it's not available, we instantiate it in a certain position, and that's it. So now we have all of our ping menu in front of us that we can eventually reference and just click one or the other options. Now we saw how to send a request, but now let's take a look how to actually responding to a request. So once again, let's check what the user ID is and if it makes sense. And let's build our response data based on what the user will click. So the response data will be a sort of a if statement. If things is accepted, mean that we will send another event and we will need to update our connection to signify that I accepted your request. So the material of the head label, which is hovering on top of my head, is going to be updated. So in this case, we are sending an event, which is still a custom event that says ping connection update. So this means that we are updating based on my accepted answer. So if you didn't accept, this of course is going to be skipped. And then we just close the menu so things basically stay as they are without any update. So now that we know roughly how everything we're doing in the system works, we really covered all of the features that we had available in this sample. Let's just take a step back and just understand a little bit what patterns and how to replicate those patterns for your own personal projects. So if you want to test in the editor and you have two previews, you can see that here I can also test. Here I have preview 1 and preview 2. If I click on this one, I should get a ping receive notification and I can accept it and see actually that the feedback material has changed. You can see all of your logs, so you can really test like you're actually on the device. If you want to test things like head pose position or hand position, I highly recommend you to test these on device because you will actually be able to understand if that's really the right track position. But nothing prevents you to test with hard-coded logic in the editor and just focus on those later in your journey developing on connected lenses. So let's summarize the most important concept of all of these tutorials. The first one is storage properties versus network events. Storage properties is handling persistent data. So you are storing data and eventually make it persist across sessions. Meanwhile, network events are just handling one-time messages without worrying about storing those informations. I think would be very helpful to understand in these terms and summarize very quickly what is happening in this project. Let's suppose that you have a board with component, purpose, and key file. The head label, you know, that handles user status and display, and you can find it, the key file is head label object controller. The ping system, which handles connection request, is handled by the ping menu. The hand menu, which handles the settings interface, is handled by the hand menu controller. And finally, syncing keys and data structures is handled by the real-time store keys. So you might know that this is pretty much the structure that you want to have if you are building a project of this kind. So let's take a look at the final demo. We built all of this project, we went through an overview together, and let's see all the pieces coming together finally. Sean just joined my connected lens session. I'm going to update my status, and he's going to update his status. We both know now that we are willing to chat or grab a coffee together. Now I want to ping Sean, and I'm just gonna lift my right arm, and I'm just gonna target the label on top of Sean's head and just pinch. What happens is that Sean's got a notification, and he will be able to decide if he wants to accept my invitation or not. Fortunately, he accepted my invitation, and I see a feedback on top of his head label, and now he's been pinged and is part of the session with me. Now Sean could eventually exit this ping anytime. He just needs to look at his right hand, invoke the hand menu, and click on exit ping. I hope that this project about connected lenses offered you the basics for what you need to build very cool lenses with spectacles. Don't forget that we offer extensive documentation about this topic too. So if you go on the spectacles section here on our developersnap.com documentation, you can find an overview regarding the topic. And if you're interested on how the technology works, you can look into the Spectacle Sync Kit. This overview of the Spectacle Sync Kit focuses on the most important part of how connected lenses work, and you can also go on the features section and deep dive on all of the features one by one. And finally, don't forget that we have a great community of developers on our Reddit. If you want to be part of a community of almost 2,000 developers using spectacles, just go on reddit.com/spectacles. You will find here a lot of posts with demos, and you will find a lot of requests for help that we are assisting on a daily basis. So if you meet any difficulties in your workflow, do not hesitate to reach out on Reddit. I had so much fun building Think Out Loud with you. This connected lens really makes me think about a future where social network turns into spatial social network. I can't wait to see what you build with this.